Ladies and gentlemen, boys and girls, children of all ages, welcome. My name is MD Wells, and I am silly and ridiculous, energetic and optimistic, intelligent and well informed, and highly creative. I intend to talk to you about many things on this particular channel. Sometimes I'll talk about games, sometimes I'll talk about toys, movies, philosophy, uh, this, that, and other thing, whatever comes to mind. And sometimes I'll be talking to you about science. Today, I would like to talk to you about science and fake news. You've probably heard the term fake news over the last couple of years. Well, when I was growing up, we had a different word for that: lies. Anytime you hear fake news, just know that they mean lies. These are lies. The problem with lies is it can be really difficult to tell the difference between the truth and a lie. Well, how can we tell? It can be hard. It can be really hard to tell the difference between a truth and a lie. That's why we invented science. Now, some people will tell you there's two kinds of people in this world: people from column A and people from column B. I don't believe that. I believe there are six kinds of people. Well, there's a lot more than six, but in this case, we're going to talk about six kinds of people. And I'm going to introduce you to them now. First, this is a good friend of mine, and she's only about 4 years old. She doesn't know nothing yet. So she is a seeker of the truth. She doesn't care what's true or not. She just wants to know what it is so that she could have the right ideas in mind. Maybe it'd be helpful if we had an example. In the spring of 2017, I was on social media and I got a friend's request from somebody who I didn't recognize. So I searched their page. Did I know this person from school? Did I used to work with them and I just don't remember them? No, that didn't turn out to be the case. But they sent me a friend's request anyway. Anyway, the most interesting thing I've learned about this person is that they were a flat earther. To which my initial response was, wait a minute, what the? How could anyone be so stupid? Wait a minute, stop. I almost called this person stupid. But let's think about that for a minute. This person has three basic claims. One, I've been lied to. Well, let's see. I'm an adult. I have two parents, four younger siblings, and I am an adult. I'm of voting age in the United States, so I've watched political campaign. I've heard about Jesus Christ. I've heard about evolution. I've heard about the Easter Bunny, Frosty the Snowman. I have heard about Santa Claus. I've heard Republicans. I've heard Democrats. I've heard Libertarians. They can't all be telling the truth. Some of them are telling me the truth, some of them are lying, and some of them neither. Sometimes both of them are lying. Anyway, so I've definitely heard some lies. I've definitely been lied to. Premise number two: I'm wrong. As much as I hate to admit it, I've been wrong a lot. I would love to be able to honestly tell you that I have been right 100% of the time. Every single time I've ever said something, it was 100% true, and nobody's ever been able to disprove anything I've ever said. But that would be highly dishonest of me. I cannot honestly tell you that I've always been right. I have definitely been wrong. Do not trust anything I say to be 100% accurate. Test and see for yourself. Okay, so that's two premises that he's made that turned out to be right. The third premise is that the earth is flat. Now, I don't know about you, But I grew up thinking, well, we used to believe that the earth was flat, but then some smart people came along and proved that the earth was round, and we've believed that the earth was round for a really long time. Some people wrongly believe that Christopher Columbus proved that the earth was round when he discovered America, quote unquote. Actually, people knew that the world was round for a long time before Christopher Columbus. In fact, my understanding is that there used to be a popular joke back in the days of Christopher Columbus. Dude, your mama's so stupid, she still thinks the earth is flat. Anyway. But not knowing that the United States, or the land that would eventually become known as the United States, existed, Christopher Columbus thought there was a great, huge, big ocean, and if he could sail across this ocean, he could get to India faster without going over land and having to pay a whole bunch of taxes along the way. Well, guess what? There was a continent there he didn't know about. Anyway, that's not the point. The point is that some people say the earth is flat and some people say the earth is round. So you've got two camps of people. Those that believe the earth is round and those that believe the earth is flat. Now, they can't both be right. The earth has to have one shape. I mean, I suppose it could be flat some of the time and then round some of the time, but I think we would notice the change of shape. Huge, massive earthquakes or something. Anyway, so both sides will tell you the earth is this particular shape, and the evidence is obviously clear, but there is this huge conspiracy of people who are lying to you, trying to tell you that it's a completely different shape. And I cannot believe how stupid you'd have to be to believe the earth is the shape other than the one that it is. So, which is it? Is the earth round like a ball? Or is it flat like a pancake? That is an excellent question. So, with this as an example, there are 6 kinds of people. The seeker of the truth. This person is only 4 or 5 years old, and she doesn't know what the truth is. She's never heard the flat earth theory before. She's never heard the globe earth theory before. What does she believe? She doesn't have any beliefs yet. Then, you've got a couple other people. This guy doesn't care. The earth could be round, the earth could be flat. It doesn't matter to him. He just goes about his day, goes about his business, doing whatever it is that he does, and he doesn't care. Now, the next group of people we're going to talk about is the true scientist. Now, I'm not talking about somebody who is a paid scientist. Now, if you happen to believe the flat earth people, well, listen to them for any length of time. They will tell you that scientists are liars. Those paid scientists are paid by companies to lie to us and tell us that the earth is round when it's actually flat. That is not necessarily what I'm talking about. A true scientist is somebody who seeks the truth. Just like our friend here. You'll notice the little atom on her shirt. She's seeking the truth. So, a true scientist is somebody who seeks the truth, and once they find it, they tell people. So, here I am seeking the truth, and I find a true scientist. Now, if the earth is actually round, the true scientist will tell us that the earth is round. If the earth is actually flat, then the true scientist will tell us that the earth is flat. Now, there is also the deceiver. The deceiver knows the truth, but doesn't care. They will tell you whatever they want. See, the true scientist will change their beliefs to fit the facts. The deceiver will try to change the facts to fit their theories. Now we come to the last two groups. As you are seeking the truth, you will choose a teacher. I want to put my faith in this particular person. I'm going to believe what they tell me. There have been so many scientific experiments done over the course of human history. There's no way I can repeat those experiments. I can't repeat all of them. And even if I did, how am I going to make money off repeating every single one of those experiments? How am I going to pay my bills? How am I going to pay my rent? How am I going to pay my electricity? I'm going to have to put faith and trust in somebody to tell me these things. Okay, like that little atom I showed you a minute ago on the shirt. I mean, it's not an accurate depiction, but it's based on what we believe is an accurate depiction because we put faith in scientists. Whether it's actually the truth or not, I can't prove. But I'm putting some amount of faith in somebody to tell me what's going on. So, if I put my faith in a true scientist, then I am a student of the truth. However, if I put my faith in the deceiver, then I am indoctrinated into the lie. So you've got your 6 people. You've got the seeker of the truth. You've got the deceiver. You've got the person who doesn't care. You've got the true scientist. You've got the person who is a student of the truth. And you've got those who are indoctrinated into the lie. Not necessarily in that order. So, which one is which? How do we know? Well, I plan on helping you explore those questions and many more. But, once again, do not take anything I say as pure truth. I will purposely slip in at least one lie in at least one of my videos, and it's up to you to try and catch it. Now, where should we begin? Now, I'm going to start with the flat Earth and the globe Earth model and see where we go from there. So let's start with the globe Earth model. This globe is probably familiar to most of you. Alright, let's start at the beginning. An egg has a yolk. In the same way, the Earth also has a yolk. Only the Earth has a metal ball made of nickel and iron. This metal ball is surrounded by an ocean of liquid rock. That can be kind of hard to wrap your mind around. For everything that exists, if it gets hot enough, it will either burn or melt. Rocks are no different. Here's a candle. If I was to light this candle on fire, that wick is going to burn, and yet the wax will melt. The glass that is containing the wax, if it gets hot enough, it will melt. I have many action figures in my collection. Many action figures. This guy is made out of plastic and metal. If he were to get hot enough, he would melt. Sometimes I like to think about, who would win a fight between one fictional character and another. It can be very entertaining. However, I shouldn't have such conversations with at least one of my siblings because their answer is always the same. If this fictional character were to get in a fight with me, I would just stick him in the microwave and zap him until he melts. This is not an acceptable answer as far as I'm concerned. Anyway, So, if a rock gets hot enough, it will become a liquid. So, whenever a volcano eruption happens, this liquid rock, known as lava, comes out. Now, for reasons that I'm not entirely sure of, while the liquid rock is underground, we call it magma, and when it is above ground, we call it lava. But that is a minor issue. Okay, so the Earth is a round ball made up of giant plates of rock floating on top of this super hot ocean of liquid rock. Furthermore, when these giant plates of rock move across the ocean of liquid rock, they often hit each other. This causes earthquakes. Different kinds of earthquakes can be caused depending on how they hit each other. Scientists believe that mass somehow... Okay. When I was talking to this flat earther that I mentioned earlier, he hated the word gravity. And every time I used the word gravity, he was like, gravity is a lie, mass does not attract mass. I stopped using the word gravity. He still yelled at me even though I didn't use the word gravity. And I started referring to it as the falling force. I said, okay, let's forget gravity. Let's just refer to the falling force. And by the falling force, I mean whatever causes things to fall. Okay, that plastic toy fell to the ground. Why did that work? If I take something that is made of glass or plastic or wood or metal, it all falls to the ground. What causes that? Whatever that is, we're going to call that, well, Isaac Newton called it gravity. But if you don't like the word gravity, then let's refer to the falling force. By the falling force, I mean whatever it is that causes things to fall to the ground. And in a future video, I will probably be discussing several theories on what causes things to fall and why I don't think some of those answers work. For example, some people believe it's electromagnetism. There is a strong magnetic pull towards the ground. Here's the thing. There are these things called VHS tapes. If you were alive in the 1990s or know someone who was, you can talk to them. And basically, a VHS tape has a magnetic strip. So anyway, this magnetic strip there we go. So this magnetic strip somehow records movies. We have very strong magnets that can erase these VHS tapes. So this VHS tape exists within Earth's electromagnetic field, and it can exist for decades while storing this movie, but 1 second being exposed to the super strong magnet completely erases it, which means this super strong magnet is stronger than the Earth's gravitational field. So if I hold this super strong magnet above a plastic toy, it should pull the plastic toy up, right? But it doesn't, because the electromagnetic field doesn't work on plastic or wood or glass. And yet somehow these objects, cloth, why is cloth pulled to the ground, but it won't be pulled to my super strong magnet? The answer is that electromagnetic fields have nothing to do with the falling force. Anyway, getting back to what I was saying a moment ago, scientists believe that mass somehow warps time-space. And that causes mass to be pulled towards other mass. This means that all things on Earth are pulled towards each other and towards the planet's core. Though the pull towards the planet's core is much stronger and you can't feel the gravitational pull on you from a toy on the other side of the room. So, this toy has some amount of mass. This toy has some amount of mass. Therefore, according to scientists, this toy, with its mass, is warping time-space. And that is causing a gravitational pull, causing other things to be pulled towards it. Well, then why isn't everything forming into a huge ball of mass around this toy? Well, because this other toy has more mass than it. And the ground has even more mass than that. So the planet's mass is pulling so hard that it overcomes the gravitational pull of these smaller masses. Anyway, this pull towards the Earth's core means that it doesn't matter if I'm on North America, South America, Europe, Asia, Africa, or Australia. You're not going to fall off the planet because you're on the wrong side. Oh no, here I am on Australia. I'm upside down. I'm going to fall. That doesn't make any sense because we're pulled towards the planet's center. No matter where on the planet you are pulled toward the center. To put it simply, up is a two-letter word meaning the opposite of down, which is only relevant with a Up is a two-letter word which means the opposite of down, which is only relevant within a strong gravitational field. All right, the Earth spins on its axis. Let's look at this. So the Earth is tilted on its axis and it spins. And I'm not really paying attention to which way I'm spinning this. It could be the right way, it could be the opposite way, but it's spinning on its axis. All right. The Earth spins on its axis, so only one side faces towards the sun. There is a flashlight here. This flashlight represents the sun. So you'll notice that one side of this planet is very bright. The other side is very dark. Well, guess what that represents? Only one side faces towards the sun. That side has daytime, and the other side has nighttime. Because the Earth is rotating, the part of the Earth that experiences daytime is constantly changing. So, if I put the sun right here, and we look, so it's daytime here, and nighttime there, but, oh look, as the Earth rotates, different parts experience daytime and nighttime. And oh look, it's sunrise here in Japan. The sun is rising in Japan, and now the sun sets in Japan. And there's the United States. The sun is rising in New York, and now it's rising in California. All right, so. Oh, what do you know? I was spinning it in the correct direction. Okay, so. All right. Now imagine an old style clock. You may not be familiar with the old style clocks, but they have hands. Now, try to imagine the sun is a glowing ball in the center of this clock. And actually, let's look at this candle. Now, if you can imagine this candle being lit, then we would have a bright sun right here. And then the hour hand moves this way along the clock. it points at 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 6 o'clock. Anyway, so as the Earth is sitting on the tip of the hour hand, then over the course of a year, it goes around the face of the clock. At night, so if the Earth is right here, the side facing towards the sun is daytime, but the side that's not facing towards the sun is experiencing nighttime. So then you would see whatever stars are around here. So imagine the zodiac constellations forming a ring around the edge of this rim here. So if Aries is right here and Scorpio is over here-ish, then you can't see Aries and Scorpio in the night sky at the same time. If Aries is here and the Earth is here, then at nighttime you're going to see Aries. But you can't see Scorpio. You're going to have to wait till daytime to see Scorpio. But then, when you look towards Scorpio, the bright sun is in the way, and it's completely blocking out the light. So you are not going to see both at the same time. Okay, let's see. So you're only going to see whatever stars are in that particular direction. Now let's talk about the changing seasons. Now, in order to talk about the changing seasons, I need this piece of paper. And this Pokemon card. So, for the changing seasons, imagine this Pokemon card. Now hold it up so that it lines up with the paper. Now you'll see that there are a certain number of lines that pass through the card. And if you hold it straight, many lines will go through the card. Yet if you tilt it at an angle, not as many lines are passing through that card. Hold on, let's count them. 1, 2, 3, 4, 5, 6. 6 lines are hitting this section of land. If I do this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's over twice as much. Now, of course, I was just choosing an angle at random. But still, you see that there are more lines passing through this edge of the card. So, fewer lines will go through the card. These lines are the rays of sunshine. Due to the Earth's tilt, different parts of it are tilted towards the sun at different times of the year, which we can see if we bring back our little globe. Now, right now, you can see that the southern hemisphere is tilted more towards the sun. So right now it's summertime in the southern hemisphere, but it's wintertime in the northern hemisphere. But as the Earth rotates around the sun, let's imagine the sun is right here for a moment. This Earth is going to go around the sun. It's going to maintain that tilt. And so now, sunlight's going to hit from the other side. So now, you see that it's aiming toward, it's more, the northern hemisphere is leaning into the light. So now it's summertime in the northern hemisphere, but now it's wintertime in the southern hemisphere. So, that's why the northern the northern and southern hemispheres experience the seasons differently. So, during the summertime, more light hits a given area, and in wintertime, less light is hitting the same area. Does that all make sense? That's the round Earth, the globe Earth model. But what does the flat Earth model look like? That's a good question. The flat Earth model is considerably different. Once again, we're going to think about a clock. Earlier, I had the sun in the middle of a clock. And the Earth was going around the hour hand. But now, we're going to say that we use a pie plate. Well, maybe not a pie, but imagine a pie plate. So, if the Earth is a pie plate, then the North Pole is at the center of that pie plate, and the edge of the pie plate is Antarctica. Now, what does that mean for us? Well, imagine filling that pie plate with water. Well, it kind of would look like this, actually, if you imagine the wax is the water. But imagine that there are rocks inside your pie plate. Okay, if you've got rocks in a pie plate and you fill it up with water so that most of the rock is underwater, but some of the rock is sticking up, those are the continents. And the very center of that pie plate, you've got the North Pole. Now, Antarctica would be the ring. I apologize for not having an actual pie plate here. I just moved and I don't have everything out of storage yet, or out of boxes, I mean. Anyway, so Antarctica is this ring around here, and so the water stops when it gets here because it can't go any further than that. There's this wall. There's this giant ice wall. This Antarctica. And so you've got the North Pole in the center, and you've got all the land around it. All the countries are spreading out from there. Now, in this case, the sun is a spotlight. It shines down and it rotates. It rotates around like this. This is kind of like the hand of a clock now. So imagine an hour hand with the sun on the tip of the hour hand shining down. But there's also a minute hand. And in this case, well, actually the sun would be on the minute hand and the moon would be on an hour hand. And the moon would have to be slightly lower than the sun, because we do every once in a while have eclipses. So they're approximately the same height in the sky, but the moon is just lower enough that it can eclipse the sun on rare instances. But then, how do we explain the zodiac constellations? So, there is a giant bowl. One moment. This is the Sky Dome, the Star Dome. I know, it doesn't look like it. Anyway, so imagine that the inside of this dome has all the stars. Now, whether they are Christmas tree lights, or there are holes in the dome that let light through, or whatever it is that stars actually are, let's ignore that for now. they are in this dome. And it's over the Earth, and it rotates. And over the course of a single night, it rotates. And that's what causes the stars to appear to rotate in the sky. Now, in the globe Earth model, the Earth is spinning on its axis. So over the course of a 24-hour period, it rotates once. And as a result, we see the stars appear to move. Well, in the flat Earth model, the star dome is also rotating. No, not also. It's a completely different thing. Let's not confuse these models. One mistake a lot of people will make is they will try to mix things between the two models. If I say something is true about the round Earth model, it does not apply at all to the flat Earth model. And if I say something applies to the flat Earth model, it does not apply at all to the globe Earth model unless we specifically say so. So, in the flat Earth model, the sky dome rotates once every 24 hours. Also, the sun rotates on its hand once every 24 hours, illuminating every part of the Earth once in a 24-hour period. Now, which of these models makes the most sense? Well, we're going to be getting into that later, but right now, we've been talking for about 37 minutes now, so I'm going to end this, and I will talk to you later. Till next time.